Yes, hello, thank you. It's hard to imagine that it's already a year past since I sent here the last year. Um, my predecessor spoke about the need of hydrogen for steel, so the client base. We now have the pipelines. This is really the connecting part between our project and the clients. And now you will hear something about where the green hydrogen will come from, and where also the main focus of HH2E is on. You know, we have the necessity to transform from fossil energy to renewable energy. We all know that we have a physical fact that the sun is shining. That means more or less, when the sun is shining, more or less all the PV systems are producing their peak power in the same time. And then we have a lot of hours where we have cloudy days like today, or simply nighttime when we have nearly no electricity consumption. That fact leads to the fact that number one, we have a cannibalization in prices. This is already, if you're going to the exhibitions where the solar branch is meeting, it's one of the main hurdles for new installations to get finance. That simply the value of renewable energy is going down because of the timely correlation. I mean, some people call it the duck curve effect. I mean, that was very often communicated. So during noon, the prices for renewable energy goes down to zero. And it also leads to the fact that we have a lot of curtailment. So green electrons that could be produced by wind turbines or by solar modules were curtailed. The machines were stopped from working simply because the grid is not capable of taking up these peaks. And in a way, it doesn't make any sense to build the electric grid based on the peak load production of renewable assets. Our history was very much focused on building renewable energy system, 100% renewable energy system. With my former company, Unicos, we experienced when we changed islands, physical islands in the ocean, from diesel and heavy fuel supply to wind, solar, and battery supply, that even if you do an optimized design for a renewable supplied energy system, you end up with something like 30 to 40% what we call excess energy. That's energy that the wind turbine can produce, that the solar module can produce, but you have no use on the electrical side. So this is, in a nutshell, is the motivation behind HH2E, and it's also the driver why our company says we want to change the game of energy. The amount that is already curtailed is enormous. It is not so much in the discussion already, but it will go through the roof with all the measures that have been taken by the government in the last 3 years. 2011, Mr. Altmaier put a class ceiling for the installation of PV and wind into place. And that class ceiling, I hated that as a solar guy, but in a way it was very well designed. It was exactly the amount of renewable fluctuating energy that could coexist with the existing fossil-fueled electric power grid. Now the government has taken away the class ceiling for solar. We have the goal to have 250 gigawatt until 2030. We have given speed to the planning processes, so a lot of new renewable will hopefully come to the market. But with that, also the congestion, so the waste of green electrons will continue if you don't do something against that. So we think that the potential that we have in our system with these electrons that normally don't find the way into the electric system, these are, in a way, to make it a little bit in our internal speech, the superheroes of the whole energy transition. So our philosophy is to collect, in a way, before we have areas of the grid that are congested, to build our power plants that are working very flexible. It's a combination of storage systems and electrolyzers. So not to look for an electricity consumption which is more or less a flat line, 8,670 hours, constant power supply. We are looking in our first installations of at least 12 hours electricity supply, but we have a technology roadmap to go until the 4 hours a day. This is what we want to achieve with a supply of 4 hours a day electricity. We want to have more or less a continuous production of green hydrogen. We are doing that in our first project in Lubmin. This is ideally located. We have enormous amounts of offshore wind landing on the transformer stations there. We have really good connections to pipelines. We are starting as a bridge with blending green hydrogen into the classical network to serve our customers. That is only a bridge. It is not that we think that this plays a huge role in the future. We also think it's not a waste of green hydrogen because there is regulation in place that is also in place for biogas, for example. So in a way, we have an existing trading model behind that. But on the longer term, we want to feed in the hydrogen into the flow pipeline and to send it all over the country. It is the first project of this type, and as we all know, a lot of projects are missing what we call FID, Final Investment Decision. That is, in a way, I think the big line that projects have to cross. And to give you an example, when we built the first bank-financed solar system, it was also here in Berlin, a 100-kilowatt system worldwide. The first bank-financed solar system, it took 4 years to convince the banks to do the debt financing for that, because only with debt financing you have scalable business. Otherwise, you will never reach the hurdle rates that equity really wants to see. So bank financing is the proof point of a project to be a scalable one. And we have now in 1 year put together a consortium of banks that are very, very close. I mean, it's more or less a formal process to give us the possibility to FID this project. And I mean, all our team, I mean, we are really fevering to get the results of the several committees inside the banks to stamp the points, and that we can also publish in a way the project start for the whole thing. Now, each and every site that we have secured as HH2E has the potential to be built up to 1 gigawatt electric connection that will then lead roughly to a 400 megawatt electrolyzer capacity on a run-through basis, so roughly equaling 40,000 tons of green hydrogen. The Lubmin route is so interesting because with the pipelines, Nord Stream 1, Nord Stream 2 landing there, we can really supply all the customers lined up down to the colleagues also of Salzgitter in Saarland. We have in the moment with our project pipeline being communicated a large request for green hydrogen. That is the good thing, a large request. Our FID will be based on bankable offtake contracts. That's also quite important. That is also possible in the moment. It's not something where you have to wait for the future. There are clients out there who are willing to pay also the price that is necessary to build such a bankable project. That is, from my point of view, really an amazing thing, because it's really the start of a huge scale-up. We are developing a whole project pipeline. I mean, the internal goal is to have sites that are located all, and also from an electrical point of view, in front of congested parts of the grid in northeastern and also northwestern Germany. And altogether, our goal is in 2030 to produce 400,000 tons of green hydrogen to clients. I mean, with all the tenders that are out there that you are pretty much more aware of than I am and my sales team. I mean, we are pretty sure that the need for that hydrogen is there, that we are the company to be able to supply it as long as it's coming to green hydrogen. So for us, it is not the goal to be part of the discussion whether it's possible to supply the whole need of the country with green hydrogen. And from our point of view, green hydrogen, homemade green hydrogen, will only have a relatively small portion in the whole game, but it will enable the overall transition because we stop wasting green electrons. Thank you.
Yes, thank you very much. Of course, a lot of questions, and we have time to answer them. Thanks, Alexander. So, there is, maybe we can look at the questions that we have. First question, which is on the RFNBO property. So there is currently no way to keep that property of your hydrogen when you blend into the natural gas grid. What would be the business case then if you are basically producing very expensive biogas?
Actually, I'm not the regulation specialist, and I don't want to tell something wrong. But in a way, it is possible. Definitely, at least it fulfills the requirement of the clients that are paying a huge uprise to the whole energy content of the gas. So there are clients in the chemical and in the petrochemical industry who are able to use also the blended gas for their purposes. Definitely. I mean, the rest, maybe if the person is in the room, I mean, we can connect to our sales guys that are also here that will answer the question more precisely that I'm able to do it.
Okay, great. What are and who are the clients who will purchase the hydrogen produced by the Lubmin project you mentioned?
I mean, the interesting thing is that the client base is a developing thing. A year ago, I would have said the only part where we are able to negotiate contracts is the transportation sector, filling stations. We have the greenhouse gas certificates as a basis. Meanwhile, the request also from the chemical industry is really going up, and we are also we're talking to a broad field of industrial clients who are preparing to take green hydrogen. The main applications that are coming on top of transportation in terms of heavy trucks is now the shipping sector. We have very strong regulations showing up from 26 on for the ship industry. Also, the amount of energy that ships are using is much higher. And on the long run, we also see us as a supplier of green hydrogen. This is on the long run, it's 2030, for example, for sustainable air fuel production, where we are part of a consortium that was in the press, even with Chancellor Scholz signing up the feasibility. So the airline industry will also be a big off-taker.
Okay, good, very interesting. Thank you very much. Do you use seawater for electrolysis in Lubmin?
No, we don't use seawater. Not now. I mean, there is also a possibility, and it's also cost-wise. It is possible to use desalinated water, but in general, we are adjusting with all the locations on each sites to use either wastewater or water resources. All our power plants are located at former fossil power plants, nuclear and fossil power plants, where you used a multiple of the water for cooling purposes before. So we have already a strong eye on the selection of the sites when we are looking for the right.
So no plans also for either for seawater. Okay. How many full operating hours for the electrolysis are you planning to have? Are you calculating with PPA and or direct connection to renewable energy sources?
I mean, in the end, you have to. We are looking to keep under 4,000 hours of electricity consumption in a year, and really focus on the cheap hours when you have a surplus of renewable energy in the grid, because we are using a system that is nearly half designed with battery and electrolyzer. We are ending up between 6,000 and 7,000 hours of electrolyzer operation due to our modeling in the moment. We will see how this is developing in the future. Also, we have a technology roadmap, as I told you, but in the moment that is the case.
Okay, thank you very much. So now, as I said, the motto is not wasting green electrons again, but if we don't waste electrons, which had forced prices to zero, then there is demand for them and the price will not be zero. How much do you expect to pay for wind and solar power?
I mean, if you are on a stock exchange, you have also money and paper, and they have to come together to fix a price. Okay, if you have an oversupply of material, you need only to have a bid that's a little bit above the actual pricing, and you will get the deal done. But actually, we don't know. In our modeling, we are not calculating with zero. So much to say. I think if you are looking between the 20 and 30s of a megawatt hour, that makes the whole system much more sustainable, because it helps also the solar and wind parks that we are signing up PPAs with to increase their value. Because in a way, in the moment, if they are looking for finance and they have to fight with all these hours with zero pricing, I mean, that is not a basis for a future bank finance. So if we can lift that to that level, I think that helps everybody a lot.
Good, thank you. Will the batteries also be able to participate in auxiliary markets while providing the baseload electricity? How come that only few developers go that route with battery and electrolyzer?
To answer the second question first, why only so few developers go that combined route? I cannot answer. You have to ask them. I mean, I have no idea. I mean, we are in business with batteries since 2008, when we installed here in Berlin the first 6 megawatt hour, 1 megawatt battery. We have developed in these times the stacked revenue models for batteries, which is now the standard business model all over the world. And so maybe it is that we are a little bit more familiar with batteries, also with how to run them. I mean, in a way, you could use the battery that we have, at least a part of it, also for auxiliary services. To keep the things easy, we kept that part out of the business plan up to now. So in a way, in the moment, also for investors, the whole thing is complicated enough. We haven't added a special line for auxiliary services, but as the things are developing, it will be possible to do that, yes.
Thank you very much, Alexander. And as we said, if there are further questions, please connect with him and his colleagues.